You're a data scientist toiling away at night in a financial services firm, preparing data for machine learning, and the product manager calls again. Hey, I am out here trying to transform the way we do fraud detection and churn analysis in this company with machine learning. And you can't yet give me the data? How long does it take to prepare data? Little does he know, right? Well, today we are going to learn about how you can use Amazon SageMaker to prepare data for machine learning with ease, speed, and accuracy. My name is Romy Datta. I'm a product manager at AWS, and joining me in this conversation is my friend and colleague Kiran Kandala, who is the Vice President of Engineering, Machine Learning, and Advanced Analytics at Fidelity Investments. This is our agenda for today. We're going to go over some challenges in data preparation and how Amazon's SageMaker machine learning flow and data preparation tools help overcome them. We will go and deep dive into a few of these tools: SageMaker Data Wrangler, SageMaker Feature Store, and SageMaker Ground Truth. And we'll hear about a customer use case with SageMaker Feature Store with Fidelity. This is a rough machine learning workflow. You take data from your data lake, your raw data in your data lake. You do some labeling, some data wrangling, cleaning up, some feature engineering. You use those features for training your model, and then you deploy the trained model for inference generation. And that deployed model uses a subset of the features used for training. A lot of the work out here is just the data preparation. Data preparation accounts for 80% of the work of data scientists. Some of these tasks are just cleaning and organizing data, collecting data sets, building training sets, and so on. It's a time-consuming process. It's a resource-intensive process. It requires multiple tools. And many of these tools are typically not DevOps friendly. And a lot of common data preparation tasks require you to write code. All of this just adds up the time out there. And it gets even worse in large organizations where different parts of the organization or different teams would probably be repeating the same process. This shows a financial services firm with multiple teams with having their own data sources, as well as pulling from data sources of other teams. Okay, so you have checking account team, you have the credit card services team, and they're all probably repeating some of the processes, okay, and just, as we call it, reinventing the wheel or duplicating the work. To understand how Amazon SageMaker can help you prepare data with ease and speed and accuracy, let us understand what Amazon SageMaker is. It is the most complete end-to-end platform for machine learning. It has a wide range of tools in 4 categories. Prepare, which we'll go over today, things like Ground Truth, Data Wrangler, Feature Store. Tools to build your models with Studio Notebooks. Tools to, a platform to train your model, where you can do single instant or distributed training. And then once you've trained your model, you can easily deploy in an endpoint and serve inferences. This is how the SageMaker machine learning workflow looks like. You would pull in data from your, let's say, S3 using a processing job, or using SageMaker Data Wrangler, which has processing jobs, SageMaker processing jobs firing underneath it. You would pull in the data, you would do some basic transformations, you might do some feature engineering and store it into SageMaker Feature Store. You can take the data from SageMaker Feature Store and create a training data set, run your training job, okay, which will run for the duration of the job, and then spin up the instance for a duration of a job, and then spin down the instances, store the model artifacts of the trained model in S3, and from which in turn from there you can take those the trained model and deploy it in a hosting endpoint, and you can serve a subset of the features you've used for training to the hosting endpoint for inference. So let's look at the first of these data preparation tools, Amazon SageMaker Data Wrangler. It is the fastest and easiest way to prepare data for machine learning. You can quickly select and query data from a large number of sources. We support Amazon S3, Athena, Redshift, as well as Snowflake. We can import data in various file formats such as CSV or Parquet files. Once you've imported the data, you can easily transform the data using over 300 built-in data transformations of Data Wrangler, or you could author your own custom transformations in PySpark, SQL, and Pandas. You can look at your data visually. We have a suite of pre-configured visualization templates, which include histograms, scatter plots, etc., to look at your data and see if something is out of normal. And once you have done the ingest of data, cleaning it up, data preparation, visualization, you can deploy this entire workflow into production, either by exporting it into a notebook or Python code, or integrating your workflow with SageMaker pipelines, or publish the created features to SageMaker Feature Store for reuse across your teams. So let's take a look at the demo for SageMaker Data Wrangler.
Okay, so let's take a look at a demo of SageMaker Data Wrangler. This interface you see out here is SageMaker Studio Launcher. So you can go out here, look for the Data Wrangler component, and we will start a new flow. Let us assume that we are solving your product manager's problem out here. We are preparing data for the product manager to do all kinds of fraud detection, etc., in the financial institution you work for. So first, with SageMaker Data Wrangler, you can quickly select data from Amazon S3 or Athena or a few other data sources. We go out here to our SageMaker, to our S3 bucket. There are two files we want to use to prepare this data for, for your use cases. The first one is an identity file, which has transaction IDs and other details related to the transaction, like IP address, phone number, etc. We import this data set. Now we into Wrangler easily with a click. Now we go back and we want to import the other data set, which is transaction.csv file. This one has transaction IDs as well as other information like card number, card type, transaction amount, whether it was fraud or not. We import this data set too, again with a click, and now we want to join these two and merge it into a single set. So you do join, you click on this, you want to join the two, you have to configure the nature of the join. Go out here, do an inner join, select the field on which we are joining, transaction ID, and just apply. And now we have our joined data set merging the two files for which could be used for fraud detection and other use cases in your institution. Of course, the transaction ID, credit card types, etc. We add that as a step. Now that we have imported the data and performed a join to create a data set, we want to analyze the data set and see if anything is out of the normal out here. So we just go out there, add analysis. There are a lot of predefined analysis types, as you can see out here in SageMaker Data Wrangler. Let's pick one which is a scatter plot, and we want to do a scatter plot of credit card numbers and the transactions on that, the amount of those transactions, and see if everything looks good. So we just do a preview out here, and you can see that nothing seems out of the normal out here. You have some, high dollar amounts, you have some low dollar amounts, different credit cards, etc. So now that we have looked at the data, let's go back to the prepare step. We want to do some transforms on this data to make it easier for usage in machine learning. So let's add a transform. We have mentioned that there are about 300 predefined transforms in SageMaker Data Wrangler. And in addition, you could also write your own custom Python transform. Right now, we will just take one predefined transform to format string. We will transform all credit card types, which you see out here in this column, into lowercase. So we apply the credit card type out here, and then we just do a preview. This looks good. I can see that all the credit card type field has been selected, has been converted to lowercase. And I just add this as a step. Okay. Now what we have done is we have gone out there, we have done a bunch of steps. We have done we have done a join, and then we have done a format string transform on the first join. Now we are ready to actually export this data. Okay. So you have multiple choices when it comes to export. You could actually export it into Jupyter Notebook or as part of SageMaker, part of SageMaker pipelines, or as the option we'll select out here, we'll save it to SageMaker Feature Store via Jupyter Notebook. Using this option, auto generates a SageMaker, a Jupyter Notebook, okay, which will enable you to create the feature groups, okay, create a feature group rather, okay, and then once you have created the feature group, you can define the inputs, which are two files out here. The two files we had talked about in S3, which are in S3, identity and transactions. We upload the actual flow, the flow we had developed, the flow we had just developed with Data Wrangler, which involved joining the two files and then doing some transforms on them. And then finally, we configure a processing job, okay, a SageMaker processing job, and ingest the data into the feature group out here. So that concludes the Data Wrangler demo.
Okay, that was a demo for SageMaker Data Wrangler. Now let's look at the next tool for data preparation, SageMaker Feature Store. Let us go back to that same financial institution we were talking about earlier. Multiple teams, checking account, credit card, security teams, they all might be recreating the same feature, okay, without a feature store. So for example, a feature like a fraud score, each one of them might be creating a fraud score for customers. Now that has two disadvantages. One is that duplication of effort, and the second is that there might be some non-standardization in practices to determine things like fraud scores even within an organization. With SageMaker feature stores, you build features once and then reuse them across teams and models. You can search for those features. It's a central repository where you can search, store the features, search them, reuse them, use it for your training data, and then you can use it for low latency serving for your inference. And when I say low latency, it is up to single digit milliseconds. And a key capability out here is to minimize any skew between training and inference, which is what SageMaker Feature Store enables. So here are some key capabilities of SageMaker Feature Store we will go through today, which will help you accelerate your machine learning. To understand Feature Store, think of the fundamental unit, which is a feature group. A feature group can be conceptualized as a table with each row being a record and each column being a feature. When you create a feature group, you can create it as online only or offline only or online plus offline, which is the one we will use for the rest of this presentation. When you create a feature group as online plus offline, the online component is stored, in the online store, which is made out of which has got DynamoDB in the backend, and the offline store has S3 in the backend. You use the offline store for model training and batch scoring, and the online store is used to serve features at high speed for model endpoints for inference. You can ingest data into your feature store through a streaming feature pipeline, which could be from Kinesis or Amazon Kinesis or Kafka, or from a batch feature pipeline where you could use something like Amazon EMR to ingest data into the feature store. When you ingest data into the feature store, we maintain feature consistency with online and offline store. And this in turn helps minimize training inference skew. When you write to a feature group which has been configured as online plus offline, the online store keeps the latest feature values for every record identifier. And these values are available immediately for use by any model with latencies, in up to single digit milliseconds. After finishing writing in the online store, the features are actually replicated into the offline store. This replication process takes some time. And for that reason, we ask customers to wait for about 15 minutes for read after write consistency from offline store. The online store keeping the latest feature always ensures also that offline store keeps the latest as well as every past feature. It's an append only mode. So let's look at an example out here. For record identifier ID1, the latest version, which is marked by a feature called event time, and I'll go into that in a couple of slides, is stored in the online store. And for that same record identifier, that latest version as well as all previous versions are stored in the offline store. As mentioned, you can do streaming ingest into the feature store. We provide a put record API, which lets you do a streaming ingest. And we also provide a capability, a SDK capability called featuregroup.ingest, which lets you parallelize the put record API automatically. It's a convenience function and lets you do parallel streaming ingestion. For batch ingestion, you could use, combined with feature engineering, you could use SageMaker processing, where you would bring your own script for feature engineering. You could use SageMaker Data Wrangler, okay, the container we provide with SageMaker Data Wrangler container, where you basically can use any of the predefined capabilities of SageMaker Data Wrangler, the predefined transformation capabilities, or you could use a tool like Amazon EMR. A key capability of SageMaker Feature Store is time trap. This is where the event time field comes into play. The event time is a user-defined dimension of time which you have to put every time you write a record. What this lets you do is it lets you go back and forward in time. SageMaker Feature Store also records two system-defined dimensions of time, the write time and API invocation time. These only move forward. So let's understand this with an example. Let's say you had a transaction with a record identifier with my name, Romy, on January 4th of this year. And there was a feature out there saying it's whether it's a fraudulent or not. And you say this was a normal transaction, not a fraudulent one. Now, sometime in April, you determined that the transaction was actually fraudulent. So what you would do is go back to event time January 4th, okay, for record ID Romy, and go out there and say that the transaction was fraudulent. Now, depending on which data set you want to use, if you want to use the latest rev, you just ask for Romy's transactions on January 4th, and it'll give you the one after the April correction if you're doing this data analysis today. But if you wanted to recreate the transaction before you did the fraudulent correction, or recreate the training data set with the transaction before you did the fraud correction, you would specify, give me Romy, the record Romy for event time January 4th, but the write time before, say, April. Okay, and that can give you basically a data set, a training data set at a particular point in time in the past. So a combination of user-defined event time and one of the system-defined times lets you do time travel in SageMaker Feature Store and recreate data sets in a particular point in time. To query from the offline store, you could use Amazon Athena or any other query tool you like. When a feature group has been configured to have an offline component, we automatically create an AWS Glue data catalog. That data catalog is what the query tool will use to will look up to do the query, and that's how you can create a data set for training or batch transform. For inference, you would read from the online store. So firstly, there are two APIs to read from the online store. One is a get record API, which lets you read a single record at a time from a single feature group. And that, as we have said, we have seen latencies as low as up to single digit milliseconds. Another API is the batch get record API, which lets you read up to 100 records from up to 10 different feature groups in a single call. Now, in it, there are a couple of inference patterns I'll go through here. In this pattern, the deployed model knows which feature to use for which features to use for the application. Okay, so the application does not interact with the feature store. The deployed model calls the feature store using either one of the APIs and gets the relevant features for the application. So the advantage out here is that the model can evolve and the app does not have to change. The second inference pattern, depending on your preference, is where the app and the application basically can directly call the online feature store, again using one of the two APIs. In that case, the application needs to know which features are needed for, and then also in case there are any changes to the model input features, there are changes needed on the application. With that, let's take a look at the feature store demo.
Okay, let's take a look at the demo for Feature Store. We use the same use case we had talked about earlier using two files, identity and transactions for fraud detection out here. Here we are again at the SageMaker Studio launcher. We go out here and I'll first show this visually using Studio, and then I'll show this using a notebook out here. So if you want to create a new feature group, you hit the launcher, the new feature group creation tool out here. I have already inputted some of the details in one of these places. So you have to select online store, you select offline store. If you select offline store, we ask you to let us auto create a AWS Glue table out here, which will be used to query the feature store. You could input a few feature values, select a type. We support three types as I had mentioned earlier: string, integral, and fractional right now. You select a record identifier out here. We just take the first one of the feature, string one, and you select another one as event time feature name. And you can add up to 50 tags for a feature group. You just hit create feature group, and you've done this very easily, created a feature group out here. So what I wanted to show is showing how to do this easily using SageMaker Studio. Now, in your data science work, you would probably be doing this using a notebook. So let's look at this notebook step by step. I've already pre-run all of these sections out here in order to save time. So in the first section, we are importing the Boto3 and SageMaker libraries. We construct the objects in the second section out here and establish a feature store session. In step 3, we provide the bucket and prefix, which is SageMaker feature store demo, to get data. We inspect the data sets out here, okay, and what we see out here is that we read the objects and put them into a pandas format and do some basic transformations like one hot encoding, etc. And you can see the two data sets imported out here: identity and transaction, and the pandas format viewing of this data. Out here, we declare the two feature group names, identity and transaction, link them to the SageMaker constructs. Then we define the schema of the feature group out here. So if you remember, we had to define a record identifier. So out here, what we have done is we have used the transaction ID as a record identifier. And we also created a feature for event time with the current time out here. And we load these feature definitions into the two feature groups, identity and transaction. And that feature definition can be viewed out here. And finally, in this step, we actually create the feature group. This step usually takes some time. As you can see, we were waiting for some time for creating the feature group out here, but now these have been successfully created. In this step, we are basically describing and printing the feature in the feature group. So you got like the feature type, the ID, event time, etc. printed out here for both the feature groups. Firstly for the identity and then for the transaction feature group out here. So now you have created the two feature groups. Okay, you can see all of the data types in this. So how these feature groups look. Now what you need to do out here is what we are doing here is ingesting data into the feature group. This is the streaming ingest API we talked about. Only thing out here is getting the feature group.ingest SDK function, which actually lets you ingest data with massive parallelism, okay, into the feature store. So out here we use that command or that SDK to ingest data into both the identity and transaction feature groups. As you can see, we have once the ingest completes, okay, we would like to actually read from the feature group. We just take a hard-coded record identifier and provide with the get record ID, we call for that record. What that provides us is the entire record. So with each of the features out here, okay, and what is the value for that particular fraud. So you can see the transaction amount was $75, for example, out here. If you also want to read from multiple feature groups at the same time, we have the batch get record API, in which you basically specify get records as a tuple. So you would specify the feature group name and the record ID you want to read from each of the feature groups names. So out here we are specifying one hard-coded record ID from each of the two feature groups, and we see that the data is outputted out here for both of the records, and for each of the records we can see the different features. For example, for the first one, you could see multiple, since we had done some one hot encoding, you can see multiple features out here. Okay, uh, you can see the different card types and so on and so forth for the transaction feature group out here. So that concludes the feature store demo.
That was the demo of the feature store. Now let's hear how the SageMaker feature store is being used by a customer. Specifically, how SageMaker feature store is being used at Fidelity. And so let me give the mic to my friend and colleague, Kiran Kandala.
Thanks, Romy. Hi, I am Kiran Kandala, Engineering Manager at Fidelity Investments. We are a team of data and machine learning engineers partnering with data scientists, leveraging the power of machine learning to provide our customers the best experience and service. Fidelity Investments is a privately owned financial institution investing 2.5 billion annually in game-changing tech platforms. We are a female-led company with over 17,000 technologists, and we're always seeking talent with a passion for data. We empower our associates to focus on new, forward-thinking ideas and technologies. I'm here to share with you all our AWS feature store adoption journey. We will start with the primary reasons for choosing a feature store, a high-level architecture that provides an end-to-end flow of a high volume and velocity use case, followed by how we are ingesting features into the feature store and how are those features being leveraged for model inference and training. Some time ago, in our conversations with data scientists, we realized that the biggest challenge for data scientists is to gather the features that they require for their algorithm. In order to be able to do that, they start off with identifying the subject areas that the model is going to leverage. And that's when we realize the importance of having a feature store. Feature store is the nucleus of machine learning ecosystem. Faster time to market is the key to success for any business. What does that mean in the context of model-driven products? When we spoke to the data scientists, the biggest, longest pole is the time it takes for a model to be developed, trained, and deployed to production. So accelerating the ML innovation by reducing the overall cycle time of our model deployments has become our goal. But it's a very challenging problem. So how do we do that? We started off based on the research that 80% of the effort is spent in data preparation, which includes feature generation. Being able to generate the features once and reuse them across various models, both for training and inference, was the key. Data scientists want to track and share features with their fellow data scientists who are experimenting with different models. But in order to be able to do that, searching to discover those features is very important. And a lot of data scientists have said that, hey, searching a feature is like finding a needle in a haystack within our current ecosystem. Every time I bet $1 to tell them that I will be able to search a feature under 10 minutes, I have failed. Especially when you have 3,000 plus features and growing, this problem becomes even more harder to find features. Also, feature consistency is addressing the difference between the model performance during training and serving, which is also referred to as training serving skew, is an important factor to be considered when measuring model accuracy. And this can only be possible if we can use the same features during training and inference. Also, feature lineage is another important aspect that we want to consider when we are predicting using machine learning models. After the model is deployed to production, being able to reproduce the model results in a consistent way is very crucial. You should be able to map which version of the feature was used by the model to produce a prediction. Tracking lineage becomes even more important when you identify a feature model drift, or when you have to provide the model explainability on how a model predicted for the compliance team. As the saying goes, garbage in, garbage out. Quality features are required to be able to produce quality predictions. We should be able to easily measure the quality of the features using tools like Deque by pointing them to a feature store. Low latency is another key factor wherein real-time models should be able to retrieve features in a low latency pattern. Overall, feature store enables all this by treating features as first-class entities. I'm going to share a use case wherein we are using customer interactions across digital channels to predict the customer intent so as to provide them with the most optimal service and experience. In order to be able to do that, we generate and ingest features into online feature store. And we do that in two modes: batch mode and real-time mode. In batch mode, we ingest thousands of features that are generated on a large population of customer data. This is done once a day based on a scheduled event. In real-time mode, we ingest hundreds of features that are generated from a stream of data captured via various digital channels. Online features offers low latency retrieval, which is important again during the real-time inference, but also features ingested into the online feature store are automatically made available in offline feature store at a 15-minute frequency. And those features are going to be used for continuous training and batch inference. I'm going to talk about each of these areas in a bit more detail in subsequent slides. This solution particularly is built on event-driven configurable architecture. We leverage managed services and serverless architecture where possible because that offers us the benefit of being able to auto-scale and make these services highly available. This also enabled us to focus on business problems rather than worrying about the infrastructure management. So, one of the first modes that we ingest features into the online feature store is batch mode. In batch mode, we generate features per subject area, also referred to as feature group, and we are using SQL-based feature generation mechanism here. Examples of various subject areas are accounts, balances, and transactions. There are roughly around 100 plus features for each of the subject areas. Some have more, some have less. Features generated for each subject area are written to an S3 location. After all the subject areas are generated, we write out a manifest file. The manifest file will have the location of each of the subject areas. We also configure the S3 bucket with a put object notification, so when the manifest file is written out, an event is generated, which is then captured and processed by Lambda. The Lambda reads the manifest file and then generates one event per subject area. Like you see here, this enables us to be able to process each subject area in parallel. And then we use step functions to orchestrate and also throttle the number of SageMaker processing jobs that we want to run in parallel. There are 5 steps in the step function. One is we check if a feature group already exists in the online store. If it does not, we dynamically create that feature group. This takes about few seconds to a minute. But if the feature group already exists in the feature store, then we compare the schema of the incoming request with the schema of the feature group that already exists in the feature store. If there is a mismatch, then we increment the feature group version. In step 2, we do some pre-processing where we do a cross-reference ID standardization. We're using Glue for this pre-processing job. And then the step function triggers off the SageMaker processing jobs. SageMaker reads the feature data from S3 that was produced as part of the pre-processing step and then ingests into feature store. This solution particularly leverages serverless architecture. This offers us scalability and configurability in different stages of the workflow. For example, we're using SQS and Lambda, a standard fan-out pattern, to be able to generate events per subject area and process them in parallel. We also use Glue for pre-processing, where we configure the number of DPUs when we are processing each subject area. So for example, balances subject area might have more records when compared to accounts. Also, SageMaker processing job offers various parameters to be able to tune and scale horizontally. For example, the number of workers, number of threads, and also the number of instances. Roughly, we are ingesting around 17 feature groups for this particular use case in a batch mode, but this whole architecture is configurable, where all we have to do is update a configuration file to be able to ingest the remaining subject areas. Now that we have seen how features are ingested into the online feature store in a batch mode for a high volume use case, let's see how we are doing the same thing in real-time mode for a high velocity use case. In real-time mode, we ingest hundreds of features that are generated on a stream of data arriving from various digital channels. When customers interact with Fidelity using digital channels, we capture those interactions as a stream of clicks. These clicks captured are then published to a Kinesis stream. We aggregate these features looking back over a 1 hour time window using Flink and EMR. Features are generated using this based on page embedding values and the clickstream data. These features are then published to SQS as events. Lambda reads those events and then updates the feature store with a real-time feature group, referred to as FGR. Also, one of the things I would like to call out is that we pre-set up the online feature, real-time feature group. And we do that to be able to maintain the low end-to-end latency SLA requirements. So even in this design, we're using fan-out pattern, and also we are using multi-threading within Lambda to be able to produce high throughput and high performance. So we have seen how we are ingesting features in batch mode and real-time mode. After the real-time ingestion is complete, there is an event that is generated, and the event router captures the event and orchestrates the inference call to the SageMaker endpoint. The SageMaker endpoint has a model that predicts the customer intent. We created a feature set library that reads a configuration file specific to the model. The configuration file is a mapping of the features and the associated feature groups required for the model. This feature set library also leverages batch get record API, which is used to retrieve features across feature groups. So in this example, you can see that we are retrieving 4 features from feature group 1, 2 features from feature group 2, and 8 features from our feature group that we have created in real time, referred to as FGR. Once the event router gets back a response of the prediction from the SageMaker endpoint, it is saved to a store. And then the downstream applications that have subscribed for this are notified. The applications use this prediction, which is defining the customer intent, to be able to provide customer service and experience. For example, if I'm visiting Fidelity online and I'm looking for my options to be able to save for college, this particular pipeline would be able to identify that intent and present to you various options available, like 529 and others. We also use the customer intent to be able to proactively present them with different questions and answers that they're looking for. We have seen how feature store is being used for real-time inference. Now I'll walk you through how we are using offline feature store for model training. Model training is an iterative process that requires features and ground truth, also referred to as labeled data. Features from offline store, these are the same that were ingested through online store, and that would address the training serving skew, along with the ground truth that's captured and any additional data from S3. We use pre-processing job to be able to create a labeled data by using those 3 data units. We are using different tools like Glue, Athena, and SageMaker processing jobs to be able to run our pre-processing step. We use SageMaker to do the train, evaluate, and tune cycles. When the new version of the trained model meets the accuracy threshold, it will be staged for deployment for production. SageMaker offers various deployment options. After the model is deployed for the first time, we use various events to trigger the continuous training pipeline. Either based on an event generated because our model monitoring detects a model drift, or it could be a use case where you want certain models to be continuously trained on a scheduled basis, for example, weekly. So we have a lot more in store where we want to leverage SageMaker. For example, we would want to build a more flexible feature generation platform where we are able to offer tools to the data scientists so that they can use Python, not just SQL, but also low code, no code options. We currently have 600 plus subject areas that we generate. We would want to onboard those subject areas to the feature store in the future. We have currently 100 plus models running in batch inference, and some of them are good candidates to be deployed as real-time models. I would like to take this opportunity to thank everyone who contributed and collaborated with us during this feature store adoption journey, and also thanks to our AWS partners for the continued support.
Thank you very much, Kiran. That was a very insightful presentation about SageMaker feature stores usage at Fidelity. Now let's go to the third tool for data preparation, Amazon SageMaker Ground Truth. One of the challenges in many applications like say autonomous driving is that machine learning models need large labeled data sets, and these data sets, the accuracy of the model in turn depends on how accurately the data sets are labeled. This is a time consuming process, and one of the ways SageMaker helps you is through SageMaker Ground Truth. SageMaker Ground Truth lets you easily label training data for machine learning at scale with 30 plus labeling workflows, assistive tooling, auto labeling, and your choice of workforce. This is how SageMaker Ground Truth works. You take the raw data, you put it in S3. You can use one of the built-in labeling workflows from Ground Truth or create a labeling job using a custom workflow. You can choose from different groups of labelers after that, and those labelers complete the tasks using the labeling UI with assistive labeling features. And at the end of the process, you get an accurate training data set which is ready for use. So that brings us to the end of our presentation. Here are some resources to get you started on Amazon SageMaker Data Wrangler, Amazon SageMaker Feature Store, and Amazon SageMaker Ground Truth. Thank you very much for your attention. Feel free to reach out to either one of us, Romy or Kiran, at the emails mentioned here.